Hi, Professor. This is Daniel Riseman with Journal Post, Creating a Good Problem. The problem I created is the following. A cube with a side of 6 centimeters is inscribed in a sphere. Points A and B are tangent to the sphere. What is the volume of the sphere with center O? Now what I did is I did a diagram, as you can see here. Now what we're going to do is we're going to use the Pythagorean theorem. We're going to use it 2 times to break this cube down, and by doing the last Pythagorean theorem we will get the diameter of the cube, and we'll do it right now. I'll show you how to break this down. The first thing students need to recognize is the fact that this is going to be a value of 6, this is 6, so what we have here is we're going to have a right triangle, a 45, 45, 90 right triangle, with hypotenuse being right here. And I'll draw that in for us right now. So because 45, 45, 90, we know this would be 6 radical 2. We'll make our right angle notation there. And then what we're going to do is we're going to go through the center of this sphere at O, going from A to B, going right through there. That's going to be the diameter. And what's interesting here is that this is actually a right triangle right there. This would be the hypotenuse, and this would be a value of 6 because every side is 6. Doing so, we're going to call this x and do the Pythagorean theorem and figure out what x is equal to. So x squared is equal to 6 squared plus 6 rad 2 squared. We do the math, x squared is equal to 36 plus a value of 72. We're going to get a value of x squared is equal to 108. We're going to square root both sides. X is equal to a value of 6 radical 3 centimeters. Now that represents the diameter of the sphere. So that's the diameter of the sphere. Divide that by 2, 3 rad 3 centimeters is the radius of the sphere. Now what we know is the volume formula of a sphere is the following. The volume of the sphere is going to be 4/3 pi r cubed. Using our r, we can do v is equal to 4/3 pi. This is going to be 3 rad 3 cubed. Doing the math, we get 4/3 pi, and this would give us a value of 81 radical 3. We can get the exact value, which I believe would be 108 radical 3 pi centimeters cubed, or we can approximate, and we'll get a value of 587.37 centimeters cubed. Well, with this problem, you can see the power of the Pythagorean theorem. Using it twice, we used it once to get this side, which was the hypotenuse in this right triangle, and we used it again to get the diameter, and using this hypotenuse to be a leg or a side, we got the other side given was 6, and this is going to be the hypotenuse. That would be the diameter divided by 2, we get the radius, and then use the equation, volume is equal to 4/3 pi r cubed. We figured this out. Thank you.